This is a Hydrate Lab simulation. This is very similar to what we would have done in class. So when you pull up the link, this is what you will see. So this is showing you copper 2 sulfate hydrate. We don't know how many water molecules are attached. That's the point, is to figure out how much water. We know copper 2 sulfate. We know that CuSO4. We just don't know how many water molecules are attached to it. So from the last video, you also learned that a lot of times they have a bluish color. That's why it's blue here. But if you click this button, the arrow, it's going to give you an initial mass amount. Now, every time you do this, it gives you a different initial mass and a different final mass. So everybody should have different answers. You should not have a whole bunch of answers that are all the same. So don't write down 0.1271 grams. Once you click on the link, it will give you the data. So let's go through what's going on. Up here is a crucible. In that crucible are 0.1271 grams of copper sulfate hydrate, and it's kind of bluish. Here we have a Bunsen burner that has a tube attached to it. This tube would be attached in a college laboratory to some sort of a fuel source that they turn on. So you would just plug it into that fuel source. Your lab tech would show you where that is. Most likely it's going to be a graduate student. And then you could turn the gas on the Bunsen burner, and that would probably be this little handle right here. You wouldn't turn the gas on until you are ready to light the Bunsen burner, because once you turn it on, there's constantly gas coming out. You don't want a room full of gas, so that would be bad. So you need to make sure that it is turned off. When you plug it in, and your TA, probably the grad student again, is going to turn the gas for the room on. If your Bunsen burner is on, it makes kind of a hissing sound. So you will hear the gas that's coming out, and then you will very shortly smell the gas coming out. If you're not ready to do your lab yet, you need to make sure your Bunsen burner is turned off, or you unplug it from the wall so that there's no fuel source to your Bunsen burner. But once you plug it in, there's a fuel source. Sometimes the place to plug it into the wall actually has a turn off also. So, just ask if you have questions once you're in your college laboratory about turning it off. They'll probably go over that. But if you smell gas or you hear the hissing sound coming out of your Bunsen burner, you need to turn it off somewhere, unless you're ready to do the lab. To light these, you'd have some sort of a lighter. They'll give that to you. It could be one that you strike. It could be a regular lighter, like you'd light a grill. It could be different things that they would use. So you would turn the fuel source on low. You don't need to turn it all the way up to get a flame. So you would turn it on low till it's just a little bit coming out. Especially in this scenario, your flame source is so close to what you're heating up, you don't need it to be really high. We don't want to waste the fuel that costs money, and we don't want to cause a fire. So use as little fuel as possible. So in this crucible, we have the blue copper sulfate plus water. And we don't know how much water is attached to it. That's the whole point of this, is to figure out what is this X. So that X represents the number of water molecules, or I'm sorry, number of water moles of water that are attached to this one copper sulfate. The little triangle just means heat. We're going to change what we have based on heat. And then here we have copper sulfate as a solid. So once we heat this, it will actually turn white because you drive off the water. And only thing left in your crucible will be the copper sulfate. And then in the atmosphere, you will have evaporated all the water off the copper sulfate, and that will be in gas form. So here's your initial mass. Again, everybody's initial mass is going to be different. So don't just copy down 0.1271, please. I'm not going to go through this so that you can do it on your own, but you would click here. It says click to start. Once you start, the minute minutes go up, it goes quickly. It goes like a minute per second. So you're not actually waiting for 20 minutes. And then it will give you a final mass right here. Those are your 2 data points that you need to write down for your lab. And based on those, you can do the rest of the calculations. If you have any questions, let me know. And I hope you guys have a great day.